Howdy everyone. In today's video, we're going to discuss how to determine if a news article is fake or real. And we're going to use Python and Jupyter Notebooks as usual. I use Jupyter for all my examples here. I love the interface. It's pretty flexible, pretty scalable. And one of my favorite things is you can do dynamic plotting and charting, including zooming in, zooming out, panning, scrolling across the chart, mouse over, and a bubble with all the details pop up. Very interactive. We're not going to do any charting today, but anyways, the theme is always Jupyter Notebooks, and there's several advantages to do that, to using this type of medium. And as always, I'm going to save the source code here and post the code with the video so you can copy and paste this, and you'll have the source for the data so you can load that into your Jupyter Notebook and see exactly how I derive all the results that I'm getting here. Okay, so you can do this for yourself. And the benefit is when you get into the code and play around with it a little bit, it's a much better learning opportunity than just reading the book or just statically watching a video. That's not a fantastic way to learn. It's very passive. If you're more dynamic and more involved in the learning experience, you're going to get more out of it. Okay, so what are the advantages to figuring out if news is real or fake? And there's tons of fake news out there now, so we have to be aware of this and try to protect ourselves against this. Certainly scalability, automated analysis, efficiency, accuracy, biases can be introduced very easily in fake news. Unbiased news should be straightforward. It should be real, consistent, right? If you have bad news or fake news, it's hard to make predictions. If you have news that's correct and accurate, it's much easier to make predictions. Real-time monitoring, integration with other tools, including API calls. So that's very important. Any kind of calculating insights into patterns of news stories and understanding misinformation. That's very important. Any kind of cost effectiveness, reduce manual efforts is another benefit, right? Increase public trust, accountability, transparency, credibility, all these things, right? So there's many benefits to understanding if something is real or fake. So in this example, it's going to be pretty straightforward, nothing super complex, but I think it will illustrate the point. And my hope is that you can take the source data, I'm going to give this to you with the code, and run it and understand how it works, and then find other data sources and plug this in here, modify the code just slightly. I'm trying to make it very generic so it can handle many different scenarios and different examples that you can feed in here, and then learn from that and adapt this code to solve your own specific customized problems. Okay, I have a file on my desktop right now. It's called news.csv. I'm going to go ahead and hit Control Enter to run this and refresh the view here. So we have the first column, it says unnamed. That's not very helpful here, so that's fine. It is what it is. I'm more interested in the title, very interested in text, and then very interested in the label. Okay, so we're going to look primarily at the text and label here, and we're going to train an ML algo to go ahead and scan through all the text and all the labels. It's going to learn what text is real and what text is fake because we have the labels here. Now, once the model learns this, you can feed in new text that the model has not yet seen, and it's going to be able to generalize and make a prediction about some text that it's never seen ever, and determine if that is fake news or real news. Okay, so we're going to feed in the same XY variables. I always do this in all my examples. The X is an independent variable, the Y is a dependent. So we're reading text and trying to predict labels, right? We're always trying to predict the Y or the target variable. We're going to do the train test split. So Control Enter to refresh. Test size is 30%, so train size is 70%. They're always the inverses, okay? We are looking at the TF-IDF vectorizer. So the term frequency is how often a word appears in a body of text, and the inverse document frequency, IDF, is how important a term is. Like, does the term occur in all of the documents? If you have 10 documents and one word shows up in one document a few times but none of the others, that's probably an important word. It could be Apple, it could be anything, it could be whatever, United States government. But if you have a word that's showing up repeatedly in all 10 documents, that word probably doesn't have a lot of meaning or significance. It's probably less informative. The words the, a, is, or, maybe, like, these words don't add a lot of context to any kind of conversation, right? We have that in our vernacular, but the keywords are the words that really add meaning and purpose to the dialogue, right? So that's what we're looking out for here. So we trained the model. We're looking at a log regression model. So this is actually a classifier. I've said this a few times before. For me, when I see regression, it seems like a regression model. This is actually a classifier model. It's a log regression model. So we're trying to predict a label of fake or real. There's only two outcomes. It's binary, okay? Here's the model's learning capability, precision recall 0.91, F1 score 0.91. So all pretty high. You want to see it's closer to 1. 1.0 is better. Anything over 0.9, if you're north of 0.9, it's pretty decent. 0.8 is okay. It's basically saying that the model is learning and making 91% accurate predictions, which is pretty decent. It's not 100%, right? It could make some mistakes, but it's going to be accurate 90% of the time. Let me go down to this cell, hit Control Enter to refresh it, Control Enter, okay. Now we have a very simple vectorizer that is able to make predictions about whether or not a string of text is real or fake. Okay, let's do a couple simple tests. This is going to be a short video, by the way. The statement, cow poop cures COVID. Do you think that's real or fake? I'm saying probably fake. Let's hit Control Enter, refresh it. This statement is fake. Okay, just what we would expect. Okay, how about this? The statement, Washington, former Florida Governor Jeb Bush will lay out a vision of American foreign policy. Is this real or fake? Sounds like it definitely could be real. And it's coming up with fake. It's coming up with fake. Let me do it again. Still says fake. Okay, you know what? I think in this case, maybe the model isn't powerful enough to determine what's real and what's fake. And this happens. We said that the model is 91% accurate, right? But 9% of the time it can make mistakes. So I think this is a mistake. This looks like it's probably real. Let's try a more advanced model, something that's more robust, more refined, and just overall a better model. This is a pre-trained model, by the way. This comes from BERT. This is fully open source. You can download this from online. We are going to set up the classifier right here. Again, this is a BERT model. And we are going to, once again, determine if a statement is real or fake. Okay, so more evolved model. The first one is a little bit primitive. Let's see if this is real or fake. It's time to reconsider lifetime appointments to the Supreme Court. That's the statement right here. Okay, and that sounds like that's plausible. That could be believable. That sounds like it definitely could be real. And that's what the model comes back with. True, it says this statement is true. So that's true news. So here's an example of where the model made a mistake. 91% of the time it's going to be accurate, but 9% of the time it will make errors. This model made an error, so we had to go with a more robust model. And there's a bunch of pre-trained models out there. BERT, ChatGPT, there's a few I played around with. So I would definitely encourage you to explore what's online and go ahead and see what you can find and how you can implement that into making your own predictions about whether or not news is real or fake. Control Enter. Here's the last example here, almost done. And this model is 99.91% accurate. So almost 100% of the time it's going to make correct decisions, right? Again, a more evolved model, not as primitive as the first one that we experimented with. And that's fine, right? Sometimes with these data science experiments, you have to try different ideas, different concepts, tests, different thought processes that you have, and then see what the outcome is. It's called an experiment because you don't know what's going to happen in the end until you run it and see what the results look like, right? So I think this was a good example. I think we're pretty much done here. Hopefully you learned a couple new things today. Thank you so much for your time and have a wonderful day.